After studying this module, you shall be able to know how to design a research, learn different types of research designs, identify which type of design applies to which kind of problem under investigation, evaluate the merits and limitations of each research design. Introduction. As soon as we see a beautiful, well constructed building, human potential at creating such wonders amazes us. The skyscrapers, the revolving restaurants, the wonders of the world, and even the simplest of all these, our own homes, have a lot of thinking behind them. Before any building gets constructed, a layout of how it is to be constructed is formulated in the form of a map. On a sheet of paper, a skyscraper gets down, modified and finalized. This becomes the guiding plan for the constructor and the laborers involved in building that piece of work. Just as we have a plan for construction of buildings, we also have a layout or plans for doing a research. This plan is termed as the research design. The design versus method. Design versus method. Research design is different from the method by which data are collected. Many research methods text confuse research design with methods. It is not uncommon to see research design treated as a mode of data collection rather than as a logical structure for the inquiry. But there is nothing intrinsic about any research design that requires a particular method of data collection. Although cross-sectional surveys are frequently equated with questionnaires and case studies are often equated with participant observations, data for any design can be collected with any data collection method. How the data are collected is irrelevant to the logic of the design. Failing to distinguish between design and methods leads to a poor evaluation of designs. Equating cross-sectional designs with questionnaires or case studies with participant observations means that the designs are often evaluated against the strengths and weaknesses of the method rather than their ability to draw relatively unambiguous conclusions or to select between rival plausible hypotheses. Quantitative and qualitative research. Similarly, designs are often equated with qualitative and quantitative research methods. Social surveys and experiments are frequently viewed as prime examples of quantitative research and are evaluated against the strengths and weaknesses of statistical, quantitative research methods and analysis. Case studies, on the other hand, are often seen as prime examples of qualitative research, which adopts an interpretive approach to the data, studies things within their context, and considers the subjective meanings that people bring to their situations. It is erroneous to equate a particular research design with either quantitative or qualitative method. Yin, in 1993, a respected authority on case study design, has stressed the irrelevance of the quantitative and qualitative distinction for case studies. He points out that a point of confusion has been the unfortunate linking between the case study method and certain types of data collection. For example, those focusing on qualitative methods, ethnography or participant observation, people have thought that the case study method required them to embrace these data collection methods. On the contrary, the method does not imply any particular form of data collection. which can be qualitative or quantitative. Research design. The meaning of research design. A research design is the blueprint of the detailed procedures of testing the hypothesis, collection and analysis of data so as to combine the relevance of the research purpose with economy in the procedure. It is a sequence of steps carried out before beginning the actual research to ensure that the relevant and appropriate data will be collected. The preparation permits objective analysis of the hypothesis formulated in correspondence to the research problems. It enables the researcher in testing the hypothesis by arriving at valid and objective inferences regarding the relationships between the independent and the dependent variables. It is the conceptual structure within which research is conducted and is an outline of what the researcher will do beginning from writing the hypothesis, its operational implications to the final analysis of the data. Purpose of research design. The function of a research design is to provide maximum amount of information relevant to the problem under investigation in the minimum cost. It answers research questions objectively, validly and economically by suggesting the researcher as to how to collect the data for testing hypothesis, variables that should be made control variables and methods of manipulation appropriate in the context of current investigation, type of statistical analysis to be followed and the possible answer to the research problems. Thus, it enables the researcher to systematically arrive at a valid and objective answer to the research questions. A research design also acts as a control mechanism and it controls unwanted variances, experimental, error or extraneous variance. A good and well planned research design should be enhancing reliability of the results produced. It gives a strong foundation to the investigation, helps researcher organize his or her ideas, helps researcher critically evaluate the flaws and inadequacies in the process, can be given to others for critical evaluation and a comprehensive review of the study. Questions answered by the research design. The research design looks at the topics under investigation, purpose of the investigation, location for conducting the study, types of data required, place for collecting the required data, time period of the study, sample design, techniques of data collection, techniques of data analysis, style of report preparation and time and cost of the study. Dynamics of research designs. Components of research design. A good research design should have the following components. The sampling design. The sampling design focuses on the method of selecting items to be observed, that is, how a sample needs to be chosen from the population so that it suffices the objectives of the research. Similarly, the other component, observational design, is focusing on the conditions under which observations are to be made. So, it talks about the context under which the observation needs to be recorded. The statistical design focuses on how many items are to be observed, how is the data to be collected and analyzed. So, the objective of statistical design is to focus on the sample size and the techniques involved in analysis of the data. Operational design focuses on the techniques for carrying out sampling, statistical and observational design, that is, the steps involved in the research and how the research needs to be carried out actually after taking cues from the other three components. So, it focuses on the practical aspects of the research. Features of research design. A good research design has the following characteristics. It minimizes bias, maximizes reliability of data collected and the data how it has to be analyzed. It gives smallest experimental error and provides maximum information. It gives opportunity for viewing different aspects of the problem. A good research design should consider the process of carrying out the study. For instance, research design must be flexible to consider different perspectives of the phenomena of the study is exploratory in nature. When associations between variables is being established, an accurate description of a situation is required. Research design must minimize bias and maximize reliability of the collected data. Where hypotheses are to be tested, the research design should permit inferences about causality apart from reducing bias and increasing the reliability. The types of research designs. The research designs can be for exploratory study. Research designs can be for descriptive and diagnostic studies, and the research designs can be for hypothesis testing studies. The research design for exploratory study. It is also called as formulative research studies. They intend to formulate a problem for developing a working hypothesis from an operational perspective to carry out a more precise investigation. It emphasizes discovery of ideas, insights, and considering different aspects of a problem under study. The purpose to formulate a research problem could be by surveying concerned literature, the reviewing hypotheses stated by previous researchers, evaluating their usefulness for future research, and may build upon existing work or formulate a new relevant hypothesis. Another method to formulate a research problem is through surveying people who have had practical experience with the problem to be studied. By interviewing them, issues and questions not previously thought about by the investigator may be raised here, and practical possibilities of doing different types of research may be discovered in the process. For suggesting hypothesis, intensive study of certain instances of a phenomenon of interest may be selected by examining existing records or unstructured interviewing, which stimulates insight through a unified interpretation. These instances may be those that provide sharp contrasts or have different striking features. Research design for descriptive and diagnostic studies. Such studies describe the characteristics of an individual, group, or determine the frequency with which something occurs or its association with something else. The former are concerned with specific predictions, narration of facts, and individual or group characteristics. The latter are concerned with established associations between variables. In such studies, the objectives may be clearly specified. Methods must be carefully selected for collecting data, keeping in mind their merits and limitations. Precautions must be taken to minimize bias and unreliability. Structured instruments which are unambiguous and minimize personal opinions are taken as the observers are involved in collecting data. These observers must be trained well and supervised as they collect the data as well as record information. Appropriate statistical analysis and test of significance should be used to draw conclusion to maximize reliability. Research designs for hypothesis testing studies. These are experimental studies involving a test of causal relationship between variables. It reduces bias, increasing reliability, and allows drawing inferences about the causality. Experimental design. The definition and purpose. A blueprint of the procedure that enables the researcher to maintain control over all factors that may affect the result of an experiment. In doing this, the researcher attempts to determine or predict what may occur. Experimental research is often used where there is time priority in a causal relationship, that is, cause precedes effects. There is consistency in causal relationship. A cause will always lead to the same effect and the magnitude of the correlation is great. The classic experimental design specifies an experimental group and a control group. The independent variable is administered to the experimental group and not to the control group, and both groups are measured on the same dependent variable. Subsequently, experimental designs have used more groups and more measurements over longer periods. True experiments must have control, randomization, and manipulation. What do these studies tell you? Experimental research allows the researcher to control the situation. In doing so, it allows researcher to answer the question, what causes something to occur? It permits the researcher to identify cause and effect relationships between variables and to distinguish placebo effects from treatment effects. Experimental research designs support the ability to limit alternative explanations and to infer direct causal relationships in the study. Approach provides the highest level of evidence for single studies. What these studies don't tell you. The design is artificial and results may not generalize well to the real world. The artificial settings of experiments may alter the behaviors or response of the participants. Experimental designs can be costly if special equipments or facilities are needed. Some research problems cannot be studied using an experiment because of ethical or technical reasons. They are difficult to apply ethnographic and to other qualitative methods to experimentally design studies. Principles. There are three principles of experimental design. Principle of replication. To increase the statistical accuracy of the experiments, each treatment is applied in many experimental units than just one. Temporally repeating the experiment also establishes the accuracy of the results. For example, studying the effect of two types of drugs on patients of depression coming to various clinics in Delhi and not just on the patients in one hospital. Principle of randomization. It protects against the effect of extraneous factors attributing them to chance. For instance, in the case of depression, some patient may be suffering from mild and other from severe forms of depression. So the effect of medicine will vary and hence the results may not be realistic. To better estimate the experimental error, we randomly take the participants for the study, which may include a wide range of patients. The principle of local control. The extraneous factor or the known source of reliability is made to vary deliberately to as wide range as necessary so that the variability it causes can be measured and eliminated from the experimental error. For instance, in the same example, the state of Delhi can be divided into homogeneous parts or blocks and the blocks may then be divided into parts equal to the number of treatments, and the treatments thereafter may be randomly assigned to these blocks. The types of experimental designs. The experimental designs can be informal or formal if we try and classify them. Informal experimental designs can be before and after without control design, after only with control design, before and after with control design, and we find that they are used in research quite popularly. Similarly, when we design a research, it can also be designed as a completely randomized design, randomized block design, Latin square design and factorial design. In these modules on research design, we are going to take up each of these research design and study them in detail. Let us see what before and after design without control has for us. In this kind of a design, the effect of treatment is equal to level of phenomenon after treatment minus the level of phenomenon before the treatment. What does it mean? It involves a single test group or area and dependent variable is measured before introducing the treatment to them. Once an initial measure has been taken, thereafter the treatment is introduced and the dependent variable is again measured after introducing the treatment. It can be represented, target population is selected and a pre-test is carried on, then the intervention is introduced and then a measure after the intervention has been introduced is taken. For instance, comparing the performance of a selected group of students before and after they receive remedial education classes. So, you have post-test, pre-test and intervention. The difficulty with this kind of a design is that with the time, extraneous variations may also come in the treatment effect and this differentiation may appear difficult. After only with control design. This design involves selection of two groups or areas, that is the test area and control area. The treatment is introduced only in the test area. The dependent variable is measured thereafter in both the areas simultaneously. So, the treatment impact can be represented as treatment effect is equal to value of dependent variable in test area minus the value of dependent variable in the control area. For instance, studying the effect of a new medicine on patients suffering from schizophrenia who have not been taking any medication in the experimental group, and the control group becomes the patients who are living their lives as usual with the illness without any treatment. A comparative assessment is made to study the impact of the new drug introduced. So, the control group is not exposed to the treatment and there is no intervention, whereas the test group is given the medicines and the measure is taken of the dependent variable is taken on them. The design assumes that the control and test group are same with respect to their behavior towards the phenomena considered. If this assumption is not true, extraneous variations might interfere in the treatment effect. But the advantage is that the data can be collected without any problem coming with passage of time. The before and after with control design. This design involves selection of two areas and measurement of the dependent variable in both the areas for the same time period before the treatment is introduced. Treatment is then introduced only in the test area and the dependent variable is measured in both after a specific time period. So, the effect of treatment is equal to change in the dependent variable in test area minus the change in dependent variable. The target population is selected and there is random assignment of the target population to the pre-test conditions. Both the groups of the pre-test conditions are measured, but in one of them, which is also called the test group, intervention is introduced, whereas the other group is not exposed to any intervention, and then the post-test measures are taken. For instance, studying the level of dance performance in a group without the flexibility enhancing exercises in the control group and introducing this program and seeing its effect on the individual's performance. So, the control group and the test group are measured, whereas only the test group is exposed to the intervention. This design avoids extraneous variation resulting from passage of time and non-comparability of test and control areas. The completely randomized design. This design involves the principle of replication and randomization. Random selection and random assignments are two features of this type of design. For instance, a fast food franchise is making and marketing two new menu items. 18 franchisee restaurants are randomly chosen for participation in the study. In accordance with the completely randomized design, 9 of the restaurants are randomly chosen to test market the first new menu item and another 9 for the second menu item. Each new menu item becomes one treatment condition. Total number of treatment conditions being excess of randomization gives every group of 9 restaurants in the total of 18 an equal opportunity of being assigned to any of the treatment conditions. One-way ANOVA, which is a kind of statistical technique, would be used to analyze data of this type of design. Thus, it includes all the variations caused by uncontrolled extraneous factors to be included under variation. We can see a diagrammatic representation of this kind of design, which is given below. Many research designs exist, but the type of design to be used must be decided by the researcher prior to collecting and analyzing data. The selection of a particular research design depends on the research topic under study. The researcher must consider the type of universe and its nature, objective of the study, sampling frame, standard of accuracy when deciding the research design for usage. Summary. A research design is the blueprint of the detailed procedures of testing the hypothesis, collection and analysis of data so as to combine the relevance to the research purpose with the economy in the procedure. Research design is not related to any particular method of collecting data or any particular type of data. Any research design can, in principle, use any type of data collection method and can use either quantitative or qualitative data. Research design refers to the structure of an inquiry. It is a logical matter rather than a logistical matter. It has been argued that the central role of research design is to minimize the chance of drawing incorrect causal inferences from data. Design logical task undertaken to ensure that the evidence collected enables us to answer questions or to test theories as unambiguously as possible. When designing research, it is essential that we identify the type of evidence required to answer the research question in a convincing way. This means that we must not simply collect evidence that is consistent with a particular theory or explanation. Research needs to be structured in such a way that the evidence also bears on alternative rival explanations and enables us to identify which of the competing explanations is most compelling empirically. It also means that we must not simply look for evidence that supports our favorite theory. We should also look for evidence that has the potential to disprove our preferred explanations. A research design also acts as a control mechanism, and it controls the unwanted variances, experimental, error or extraneous variance. A good research design has the following characteristic. It minimizes bias, maximizes reliability of data collected and analyzed. It gives smallest possible experimental error, provides maximum information and gives opportunity for viewing different aspects of the problem. The principles of experimental design have been discussed at length in the text. The different type of research designs suitable to experimental research have been taken up and discussed with appropriate examples and explanations in the text.